Next up, we delve into the economics of zero-knowledge proofs. For this panel, please welcome back to the stage Avi Zurlo from NIL Foundation, Uma Roy from Succinct Labs, RJ Catalan from yet another company, Nick Matthew. Moderating this discussion is Ray Xiao, Senior Director at IOSG Ventures. Please welcome them to the stage.
Hello. Yeah, it's so nice that we can have discussion about economics of ZKPs. I'm Ray from IOSG Ventures. We are crypto VC. First of all, before the discussion today, we'd love to have a brief intro about yourself and what your focus recently. Yeah.
I'm Uma. I'm one of the co-founders of Succinct. We're broadly focused on making tooling to make it easy for any developer to build with zero-knowledge proofs. In particular, recently we announced our plans for a decentralized prover network and also launched an open source ZKVM called SP1 that has state-of-the-art performance and is really useful for a variety of use cases.
Hey everyone, I'm Avi. I'm Chief Product Officer at NIL Foundation. NIL Foundation is a team of primarily engineers and researchers who's been building since 2018. We have a Crypto 3 library, which is C++ cryptography library. We have a proof market for sourcing proofs. We have a ZK which is a circuit compiler. And then our focus for this year is an L2, which we've coined NIL. And yeah.
Hi everyone, my name is RJ. I'm the founder of yet another company. We are building a product called EigenLayer. It's a decentralized network of verifiers, and we're using EigenLayer to make verification cheap and also more flexible.
Hey everybody. Hey, I'm Nick. I'm an investor at Standard Crypto. We're a crypto native venture fund that's really interested in ZK.
Okay, thank you guys. I prepared some questions, but I'm not sure I can cover all of them, but I try to make it. The first question is to try to let audience to have a more recap. Could you give us a little bit more background compared with 2-3 years ago? Do you have any on-chain or change in terms of the visions? We know that a lot of progression in the both academic side and product side. Compared with 2-3 years ago, I assume that I think you also have a lot of change in different focuses. You have new products, and could you give a more introductions about this side? Yeah, both product size and the research side in different focuses.
Our most recent product that we launched was this ZKVM SP1. The reason we built it is I think we had been building at our company a bunch of ZK applications for a long time, including ZK bridging, ZK oracles, and things like that. And I think as ZK developers ourselves, we kind of realized that the ZK development experience today is really horrible. You have to write all these custom circuits and all these custom frameworks, and it requires a lot of cryptographic expertise, and is just really arduous. A ZKVM lets people basically write normal programming languages like Rust and then get a proof. And I think that is really the future of ZK and the thing that will let it go super mainstream, because anyone now can use zero-knowledge proofs in their application, whether it be a bridge or roll-up or things like that. And I think that is one of the biggest challenges of this space is the developer accessibility and ease of use. And so that's why we decided to focus on that more recently, because I think it's one of the most important problems.
Yeah, I think similar to Succinct, we spent a lot of time building a variety of applications and very low-level tooling like a cryptography suite to more abstracted, easier-to-use tooling like the ZK LLVM. And I think the insight over the last few years is that research and engineering around zero-knowledge proofs has made leaps and bounds to the point where at NIL Foundation, we noticed that maybe we could apply sort of the state of the art to solve old problems, right? And this is where sort of ZK sharding came to be, where sharding has had a long-standing problem of data validity, right? But with these state-of-the-art proof systems that are really pushing the extremes of what you can do in theory, that will then be implemented in production-ready systems over the next few years, it's a great time to be revisiting these old problems that we didn't have the tools to actually solve for. So, yeah, at NIL, that's been a big change for us.
Yeah, we share more or less the same vision. Like, one of our goals is to make ZK more accessible, and we know already that a lot of people are working on the prover side and working on new ZK VMs, and at some point, developer UX and accessibility will be solved, probably by many teams. And what we figure out is, okay, if we know ZK is moving way faster than we expected, and things are advancing and actually getting way better, what is going to be the next bottleneck for ZK in order to be accessible, in particular to Ethereum? Because we believe people want to build on Ethereum, so the question we ask ourselves is, okay, what kind of infrastructure can we actually build in Ethereum that will help people use more ZK? Because we already know that ZK is already here, it's quite cheap, and it's getting way better. So, in our opinion, the main problem is the verification, and the verifier in itself is Ethereum. So what we're doing is removing verification off-chain, but we're trying to use crypto-economic guarantees to make that possible. And yeah, we have the same thesis around zero knowledge, and we believe this is the last mile in order to make ZK way more accessible, because we will lower costs, and by lowering costs as well, we'll allow people to use like the latest ZK tech made from Lambda Foundation or Succinct Labs. We're actually including the Succinct Labs VM in our MVP near soon. And we just want more people to use the latest. We don't want Ethereum to be the constraint. So taking into account all this innovation that has been happening, we are adding this missing piece of the puzzle in order to make people use ZK in Ethereum.
And we're not building anything in ZK ourselves, but we talk to a lot of the teams that do. And one of the things that's been most exciting for us is as sort of the ZK cryptography on the academic side has gotten better and better, as everyone has been saying here, there's been more and more exciting things to build in ZK. And so we're excited to see that continue.
Yeah. So back to our topics today, the economics of ZKPs. I think Nick also published an interesting article about the whole life cycle of the ZKPs, and Succinct Labs also like building like ZK VMs, and Near Foundations like doing some ZK VMs, and Line Layer doing some like verifications layer. So we have different process, like from proof generation, proof marketplace, and verification, this kind of stuff. And which part you think, like for your current like focus, which part you think could be accrue the most of the value when related to like Ethereum-based layer in terms of like applications or sequencers or any other things you think capture the most of the value in the whole life cycle?
Maybe this isn't a part that will necessarily capture the most value, although I do think it'll create a lot of value, and so hopefully it can capture some of it. But I think aggregation is really exciting because as I think Align Layer is working on, today if you want to verify a ZK proof on Ethereum, it's between 200 to 300K gas. One really magical thing about ZK is that you can recursively verify a bunch of proofs in another proof. This is called proof aggregation. And then you can take that aggregated proof and verify that on chain. So basically for 200 or 300K gas, you can verify arbitrarily many proofs and arbitrarily large amounts of compute. So that is like a clear benefit to the end ZK developer where they can just directly reduce their on-chain costs. And I think aggregation is like a really exciting area where it can make a lot more ZK applications feasible. So today, for example, your proof needs to generate $10 to $20 or whatever the corresponding dollar amount of 200K gas is on Ethereum to make it worth it. But in the future, hopefully, in the limit with aggregation, the cost of verifying a proof on chain will basically go to zero once you amortize it across all the aggregated proofs. And so I think the aggregator here is providing a lot of value. And so obviously, I think they can hopefully charge for some of that value as well.
Yeah, I definitely agree with Uma said here. And I think it's difficult to say where value lies in the stack. And ultimately, it's up to ZK application developers to decide on what kind of trade-offs they want to make. You know, as Muma had described, these aggregational layers have this really magical property that allows you to combine many proofs into one and effectively amortize your verification costs on chain. But the trade-off is latency, right? And so for ZK application developers, there's this balance that you have to strike, which is, you know, what is your latency for, you know, hard finality on Ethereum, where verification is very expensive, and what is your price sensitivity, you know, for that verification. So, and I think I don't think we've developed the ZK application space enough, because, you know, I think we're all sitting on this panel and we're all building infrastructure, right? And so over the coming years, I think we'll see, you know, some of these things start to solidify and application developers express their opinions.
Yeah, I tend to agree. I mean, I think it's too early to think about exactly where the value capture is going to be. We have been thinking about this lately. We believe maybe something like a line layer, if it has a lot of volume, can have MEV, because we decide the order of how we post the results of certain proofs on chain, and that could have, it has a relationship with the finality, Sabi has described. But we think aggregation is really interesting and useful, but we believe it's not going to solve most of the problems that we have today. So aggregation is really interesting when you want to aggregate the same type of proofs. The main problem is we don't know exactly which proving system people are going to use in the next 5 years. So we believe instead of using aggregation, by using kind of this optimistic verifiable verification oracle that we're creating, you gain in the short term like way more benefits by lowering the cost of verification and also allowing proving systems that are new, for example, new ZKPs, to actually go into production, even if they don't have the full infrastructure to have aggregation because of volume. Because if you want to aggregate, as Avi described, we have latency issues, and the latency issues are correlated with the amount of throughput you have, right? So with something as our infrastructure, people can aggregate, but it's not our decision. It will be the developer's decision. And people can choose the trade-off between latency and cost by their own. So we believe aggregation is something useful, but it's not going to solve 80% of the problem. Because if you want to move into a world with many different ZK tech stacks, it will be a really hard problem to solve. That said, we want to aggregate the same type of proof long term, but we believe we are not going to do that in the next couple of months.
Yeah, in terms of market structure, the proof supply chain has a very similar structure to the transaction supply chain. And in the transaction supply chain, the sort of value capture there is MEV. And so I think who sort of captures value in the proof supply chain is going to be quite analogous to who captures value in the transaction supply chain, which once we've built out all the necessary infrastructure, is for the most part probably going to be the front ends that sort of control the order flow or get the order flow directly from the user, because they're the ones who have the most sort of inherent leverage in the system. And so similarly, I think whatever entity in the proof supply chain has like the direct relationship with the application or user that's submitting the request to generate the proof, I think they have the most leverage. And so like once all the infrastructure is built out, you know, there's probably the most value capture there. That being said, there's a lot of sort of path dependency in terms of like who actually ends up getting that proof flow and how different entities can monetize from that. So it's still very much TBD, but that would be sort of like my guess in like equilibrium.
Yeah, regarding with like MV values captured, how do you think of Justin Drake's the proposal of like base rollups? I know you guys, some of you guys, like right now you are doing like rollups. I'm not sure. I think it's pretty new for you guys. We'd love to like hear what's your thoughts. Could you share us a little bit like ideas? Would you consider it or not?
Yeah, I think for base rollups, the value capture layer for the rollup right now, at least, is like sequencer fees and then also MEV for the sequencing of the transactions. And I think a lot of rollups anticipate that being the biggest source of revenue in the future, especially as like the margin on the sequencer fees perhaps goes down a lot. For base rollups, you're basically delegating sequencing to the L1 block proposer. And so I think the reason Justin and other people who are very Ethereum aligned are a fan of this is because it takes like the roll-up sequencing MEV value capture and directly gives it back to L1 proposers, which is like good for ETH and Ethereum. I'm not sure whether like the roll-up teams would like this because maybe they want to keep some of the value capture for themselves. But yeah, that's how I think about kind of base roll-ups and, you know, the incentives behind them.
Yeah, and I agree with Uma. To elaborate a bit more on like the economic relationship between Ethereum and like zero knowledge proof infrastructure, I share a similar vision with many others of proof sync. Check. Oh, yeah, okay. And in that is it cutting out or? Okay, test, we're back. Yeah, so we have this universe of proofs, machines that are generating proofs, and at the base layer we have the arbiter of truth, right? Who is Ethereum, right? And you want a very censorship-resistant, operationally resilient, decentralized base layer to sort of be the canonical truth of verification. And in between, you know, this constellation of machines that are generating proofs and Ethereum, you have these really interesting layers that, you know, RJ and folks are building to actually aggregate them. And again, I come back to my original comment where it's not quite clear how value flows through that system and where it lands. But one thing is absolutely certain, that Ethereum plays a very critical role in that future. And it's going to be up to application developers to decide on how that all shapes out.
Testing, yeah. So, yeah, I tend to agree. I mean, I think we'll see. The thing is, the thing what I don't agree is trying to find one type of architecture for everything, because I don't think the tech is too ready, and also like we haven't figured out, Sabi described, like when exactly do we actually capture the value. So, and many developers will choose different type of systems and where they want to actually do MEV if they want, or if they don't. There are some great teams working in using ZK, for example, for MEV for rollups like Radius. And yeah, in general, what we do believe is that we need more kind of this openness of deciding, okay, it will be up to the applications, even more than the developers, or the business logic of designing which is the best architecture for the rollup or for the users as well. And we're excited to see more experimentations, not only marrying with one single architecture to rule them all in rollups, or even in ZK in our opinion as well. But yeah, we're more pragmatic in the sense that out of people who experiment, we have to build infrastructure that can help people that are experimenting and can be long-term thinkers.
Yeah, I don't have much to add on booster rollups beyond what everybody else said, but I think it's good to see more experimentation with different architectures for rollups, and just given that they're in such an early stage of research, I don't know if we have like a clear sense of what their sort of terminal economics are going to look like, but it's certainly an experiment worth running, and we'll see how infrastructure teams and their application customers end up viewing it.
Yeah. Thank you. Regarding with like proof aggregations, I know like Lambda has like published some research, and then Near also linked some research about like aggregate some like framework A and framework B together, try to compress the ZK, and RJ have like different solutions like inherent economic security of from Ethereum and let the verification happen on off-chain. And we'd love to like note your ideas, the proof aggregations, when it become more and more mature. Do you think you would like make fundamental change to your technical architecture? Do you need to like upgrade a lot based on this? Yeah.
Yeah, I think the end game of proof aggregation just really depends on how proof systems play out in the next few years. I think right now a lot of different teams use a lot of different proof systems, but maybe that won't be so true in a few years. Like maybe there will be some settling towards like a few canonical proof systems. Just from like a security perspective, I think it's like a lot easier to deal with that audit surface. And especially if ZKVMs take off and everyone's using ZKVMs, maybe it ends up being like one or a few ZKVMs that everyone uses that are like fully open source and kind of like a Linux-like community project. In that world, if the proof systems that are being used are pretty homogeneous, I think aggregation looks very different than if there's many, many, many different kinds of proof systems. You could imagine, for example, that the final aggregation layer looks something like all these different proof systems get aggregated into one VM because you write your verifier in Rust, and then that gets put on chain. But you could imagine another world in which everyone does their own wrapping to something like Route 16, and then all those proofs get aggregated. I think it's pretty early to tell how it'll play out. So yeah, I think we'll have to see.
Yeah, I'm going to give this mic a go again. I think proof aggregation, it already plays like a really important role in, I think, pretty much every large-scale ZK application today, right? Rollups already do sort of an internalized vertical proof aggregation in batching many proofs together in order to amortize costs across transaction batches. I'm quite sure that WorldCoin is also doing something similar, right? So that's going to persist, right? I see no reason why we would go backwards. Where I think things get really interesting, and at NIL, where we're certainly excited to contribute towards, is sort of potentially heterogeneous aggregation across different proof systems. Here, there's incredible economies of scale, right? To take a proof of one proof system from one ZK application and combine it with another, yeah, I think frankly, whoever builds that is probably going to make quite a bit of money.
Yeah, I tend to agree, but at the same point, our thesis is that we don't exactly know what will happen. So I don't know if ZKVMs, I think ZKVMs are awesome and we should use them more, but I'm not exactly sure if they will have only one of them or will have many of them. Because the future is uncertain, our philosophy is, okay, if we don't know exactly how ZK will look like in the next 5 years, how can we build something that can help accelerate ZK being used today? And also, we are talking about economics, right? So incentives are important. And I think incentives, in order to keep building your own proving system for some systems, is going to be really high. Like, why a ZK rollup will abandon completely their proving system if there's a new ZK VM? I think there are many teams trying to build great tech, and the incentives to be the winner will always exist. So I don't see that disappear in the next 5 years. So taking that into account, I think we'll still have many proof systems. Therefore, we will not be able to aggregate them all together. And it will be up to the user, I think, how they want to use aggregation or not. Because as Avi described very well before, like latency is something applications have to take care of. Like, do you want to be, if you're a bridge, maybe you want to have like low latency. Or if you're a rollup, maybe say, okay, I want to have like less cost, so I aggregate more. Latency is not a big deal. So I think that decision should be up to the application. So aggregation makes like a lot of constraints to the developers. that's the way we see it, and that's why we're building something that is not married with only one proving system or one idea or framework for the developer.
I don't have a strong view as to like what proving scheme or schemes are going to be involved with proof aggregators. But one interesting question I think to consider is, I think Vital gave a talk at ECC last year where he painted this vision of like the proof singularity where an Ethereum block would just be a bunch of proofs that sort of got recursively aggregated, or maybe just like a bunch of proofs included in a block. And now people are starting to build these sort of like out of protocol proof aggregators that then just submit the one proof on chain. And so I think it'll be interesting to consider whether or if at some point proof aggregators or a proof aggregator gets enshrined into the protocol at some point. Yeah, so that'll be something interesting to explore in the future. Yeah, and I had another point that I forgot.
Yeah, about this topic, like in future, definitely we have so many proving schemes, and like you just said, like Vitalik also shared some views that we may have raised that if we rely on like certain cryptographic system, and do you think in future, like for the target audience, like for the users, do they have like different requirements, like when they have so many proving system to choose? And do we need to like do some customizations plan for the users? And about the security side, do you think is easy to like auditing those security, like auditing those codes? Is it easy to like be more automated, like than auditing a smart contract, like running by solid code?
Yeah, I actually believe that there won't be that many different proof systems in the future. Hopefully there'll be like one or a few for ZKBMs, maybe like a few for machine learning or like really specialized use cases that get a lot of benefits from having customization. But I think otherwise like the auditing and security story gets very, very tricky. Even at Succinct, we kind of encountered this where we've built and developed, I think at this point with like 4 or 5 different proof systems, and it feels a little unsustainable because basically for every new proof system you have to audit the whole stack. Like you have to audit even the foundational cryptographic primitives that are being used all the way up to how you express circuits, and I think that just becomes very difficult. So I am definitely biased, but I think there's kind of a future where everyone writes their application in something like a normal programming language, and there the audit surface is like very minimal. You use like a normal compiler that everyone already uses today that has been like well audited, battle tested, and then there becomes this kind of like hopefully super well audited canonical proof system that can generate proofs of bytecode that is like pretty standardized. And maybe there will be like, I don't think there will be just one, maybe there will be a couple, but I don't think it looks like in the limit having hundreds and hundreds of proof systems, because that just, I don't think it's very secure. I don't think it's maintainable. It's not auditable. And there's like a lot of real trade-offs that come with that. So if it's possible to have like, maybe a couple proof systems that have the same performance as the more customized ones, which I think especially with lookup-centric architectures do become really possible, that is like a much more ideal version of the future for kind of everyone involved in the supply chain.
Yep, I agree. I think we end up consolidating to a few proof systems, namely because it's just totally unsustainable to keep up with security practices for hundreds of proof systems. I also think that developer tooling is progressing really fast in such a way that it's incredibly easy to build a ZK application without ever having to touch the back-end cryptography, right? And I see no reason why these tools get any worse. I think they're going to get much better. And that actually sort of puts the onus on the infrastructure team, the developer team who's building out those developer tools to make decisions about what type of proof system they're using, about security. And coming back to Uma's point here, I think the only practical sort of end state is that we agree that there are a few proof systems that work well for certain types of computations, and these developer tooling infrastructure teams kind of join efforts, right, to ensuring we have incredibly high security standards for those. So, yeah.
Yeah, I 100% agree. I think we will see, it will be a small subset, but we will have I don't know, maybe 10, 15 kind of proving systems, like long term. In the meantime, we will have many. And yeah, I hope to see more people using ZKVMs instead of writing their own circuits. And something that we didn't touch that I think is important, because I agree 100% with everything I said, is that this will lower the cost for building in ZK. Not only for actually operating it, but actually going into production. So you will be able to go much faster into production, and it will be easier to build a team. Because today it's quite expensive, and that's also a constraint that is not a technical constraint, it's an organizational constraint that is not allowing us to use more ZK. Because a lot of great teams, they don't use ZK because they are afraid of using it, and they also don't know that ZK is already useful. So we are really excited to lower the barrier of entry, not only by lowering the verification cost, but allowing people to use more ZKVMs or systems that they currently don't use because of the trade-off they have to make in order to work with Ethereum. So we're really excited to see way more ZK applications. And we think the tooling will get, I mean, it's already getting way better.
I'm going to say the same thing as Uma and Avi, just in a slightly different way. You can think of all these proving schemes as sitting within some trade-off space, and some of those proving schemes are in very different spots in that trade-off space. So Stark's in Groth 16, and so maybe there's viable reasons to use one instead of the other in some context because they're just so different. And then there are others that are marginally different on some axes, but aren't dramatically better than some other for some given context. And so you probably see shelling points around 3 or 4, and then even if there's some other proving scheme that's slightly better for some narrow use case, people will just gravitate towards wherever the shelling point is because that has the better infrastructure and tooling and security and so on. So yeah, that's how I think it's going to play out.
I think we have already talked about economic incentive, MEV, events, but we didn't discuss much about the course. I assume that many of the audience also have the similar question as I have. Is that where are we at when we consider about cost of the estimated cost of the proof generation, proof verifications, and where we are now, and which of these are the main bottlenecks for us, and what we can expect in the next, let's say, 2-3 years to improve.
I think already today the costs of ZK are actually cheap enough to be very practical and viable in a variety of contexts. As a really concrete example, recently the Polygon team released their Type 1 ZK EVM, and the cost to generate a proof per transaction was maybe around 0.2 to 0.3 cents per transaction. Already, rollups pay at least 10, sometimes 20 cents to Ethereum for data availability, so fractions of a penny is really completely trivial compared to that. And so I think already ZK, even for a very complicated use case like ZK EVM, is extremely cost effective. And I think this is kind of a myth that ZK is too expensive. I think that's actually not very true if you look at some of the more recent stuff that's coming out. Even with our VM SP1, we implemented SP1 Reth, which implemented a ZK EVM in 1,000 lines of Rust. And it's very reusable. It uses Reth, Alloy, Revim, all these primitives, so it's super auditable. And the transaction costs for that are around 1 cent a transaction and also rapidly decreasing. So even, for example, something that's general purpose and not handwritten, like the Polygon ZK EVM, is still quite cost competitive, especially when you put it in the context of what we're already paying Ethereum for DA. So I think the ZK adoption problem is a lot around education, that actually, hey, look, the costs aren't that bad. You can actually plug this in today. Also making the developer experience really seamless. So not making it so people have to run their own proving infrastructure. And I think that's where things like prover marketplaces are really useful, similar to what us and like Nil are building. But yeah, in terms of cost, I actually think it's kind of a myth, and it's kind of all of our jobs to make it clear to people that like, hey, every rollup should be a ZK rollup, every bridge should be a ZK bridge, every Oracle should be a ZK Oracle. Like, there's no excuse to not have the best tech. Like, why not use the best tech? Why not have the gold standard instead of all this like committee-based, optimistic, whatever stuff? Like, let's just use the best tech because it's already cheap enough now.
Yep, I agree again. We're going to have to find some things to disagree on. I think to give you kind of an example or an insight into like where we're at in the market, at least for proof generation costs, the demand for proof generation is pretty inelastic. And again, this comes back to what are the ZK applications that are consuming proof generation today. And you pretty much have ZK rollups, and then you have like attestation protocols. I mean, and you know, there's a long tail, but these are sort of the primary drivers of proof generation demand. And if you look at attestations, attestations are you know, pretty cheap to generate proofs for, right? They're very small computations. So as you improve proof generation costs, you actually don't see like you know, the demand curve reacting in any meaningful way. Where you do see you know, sort of demand supply dynamics is with proof verification for attestations, right? And that you know, we can aggregate many of these together and amortize our costs. And then if you look at ZK rollups, these are, as to Uma's point, predominantly their cost structure is comprised of DA, right? And proof generation is a fraction, if that. So again, proof generation cost reductions don't actually play much of a role in increasing demand. What proof generation cost reductions do play a role in is sort of the design space for ZK applications, right? And making existing systems more trustless. And I think this is where we ultimately see proof generation cost reductions playing an impact.
Yeah, I think in this panel we all agree more or less with the same things constantly. I mean, I'm on the same page. The only thing that I will add is that, I mean, it's true, like, it's already really cheap to generate proofs, and it's going to get cheaper, like, it's a matter of time. So, taking that into account, then the next thing we should ask ourselves is, okay, what exactly is not going to get cheaper? And it's actually going to get probably more expensive. And that's the verifier that in most of these trustless applications is Ethereum. So that's why our focus is there. And yeah, I think now that with more education, and also something that was the bottleneck for many of these ZK applications was the tooling, and that's getting way better. And yeah, there's no, I still don't understand we use, to Zuma's point, like why we still using a lot of this optimistic infrastructure. I think it's also kind of an economic incentive. We are using old technology because we need to justify maybe high valuations, I don't know. And yeah, I'm excited to see many teams working and building more stuff, and especially because of the proof generation costs are going lower, and I think the verifier Ethereum will be able to make it also cheaper. I want to see more applications that are not related to blockchain, and we couldn't use them to start using ZK and be trustless, new trustless applications, like ZK peer-to-peer, for example. These type of systems that it will be easier to build because we have better tools and better VMs. So yeah, I think it's a myth that is quite expensive, and in the next 1 or 2 years, it will be extremely obvious.
One thing that often confuses people is that when somebody says that ZK is expensive, they're often not speaking economically, they're speaking temporally of saying, you know, oh, this proof takes a while to generate. But obviously that's like an absolute statement as to like something that's relative, right? Like some computations are very fast and some computations take a long time, right? So like naturally the same thing is going to be true for ZK. Some proofs are going to be quick to generate and some are going to be, you know, take a longer period of time. But over time, as all these systems get built out and as sort of ZK cryptography improves, both the cost of proof generation is going to go down, and the sort of temporal cost of generating the proof is going to go down. And so I think a lot of these issues that people raise are actually not going to be problems in the long term.
Okay. Maybe my final questions before I give the Q&A time for the audience. My final question is more about using scenario. A lot of narrative happens coprocessors, and when we look at the ZK space, the use case is mainly about scalability, like privacy, like ZK Oracle, like light clients breach, this kind of stuff. And in the next 3 to 5 years, I assume that you also have a lot of discussion from the potential clients or customers. Which kind of use case you think is have more potential upside to get mass adoption?
Yeah, I think all the things you named, roll-ups, bridges, coprocessors, oracles, attestation services are very exciting, I guess, to me personally. At Succinct, we've kind of done a bunch of different applications, including like bridging, coprocessors, oracles, and now, especially with SP1 roll-ups. I think one thing that's really exciting is with a general purpose ZKVM, where anyone can like write Rust and get their zero knowledge proof, you can just enable all of these applications and more. And the bottleneck is no longer like having an advanced team with like cryptographic expertise, having to handwrite all these circuits for all these different use cases. I think finally, like with the ZKVM, that's kind of when all of these applications can go mainstream, and then also people can experiment with even more applications beyond just the ones you highlighted. So for me, that's really exciting. Like it finally feels like the infrastructure for ZK, especially with ZKVMs, is like here. They're easy to use. Like people can experiment a lot more, and it's not bottlenecked by our expertise on our team or expertise on, like, for example, Nil's team that's very specialized. It's like truly any developer can like apply their creativity and have ZK in their app. And so I'm excited for all of the above use cases. I think rollups are a very obvious one. Coprocessor are obviously really cool. But now it's just going to like hopefully 1000x the number of developers that can experiment with stuff.
Yeah, I think the two largest ZK applications today, again, in terms of proof generation, are roll-ups and attestations. I think, because both of those have found some product market fit on a relative basis, those will likely persist and continue to grow. ZK rollups, obviously, sort of, the end game state for scaling, and attestations, in particular, private attestations for private personal information, I think make a lot of natural sense. There's a lot of synergy there with the use of zero knowledge proofs and privacy around identity. I'm also really excited about what RJ had mentioned in his last comment about ZK P2P, right? And in gluing sort of existing infrastructure together using zero knowledge proofs to attest to the correctness of the computation of these systems. And this goes far beyond just blockchains, right? And I think ZK P2P actually started as like a Venmo, or it was a Venmo on and off ramp. But you can extend this to Venmo to Swift or to Zelle, right? And it doesn't have to be necessarily on chain. So I'm excited for these three categories.
Yeah, I will say the same. Like we have like rollups and bridges are the clear. Like they are going to be the first users that are going to use more ZK. And the other one is these ZK trustless applications that we haven't seen, and we are going to see more. I want to see more experimentation, and also it would probably be easier to write a ZK application because you just use Rust than actually writing a smart contract in Solidity. That's something that I like personally. I think that will be better, and this will mean that we will have even, for example, games. Like we are experimenting a lot, where we want to include, for example, for a line the probable Doom that Rick Zero did, and we want to see people use ZK everywhere. And I think that will happen. And yeah, the main thing is not the prover. We believe that in order for that to happen, you will need a trustless layer. And for that, you need chip verification. But yeah, I mean, I think it's quite exciting what's going to happen in the next couple of years, especially considering that we live in a world that is very complicated and probably multipolar, and trustlessness is going to be extremely important for any type of system, not only money. So yeah, we want to see more things built there.
Yeah, those are all good examples. Just to add to that, maybe I'll answer a bit in the abstract. You can think of like a computation as taking like some time x to run, and then to do that computation in ZK takes some like f of x, right? Because there's some overhead over the baseline computation. And as ZK gets better and better, sort of f of x is sort of less and less of an overhead relative to x. And so I think the exciting question for people in ZK to ask is, how do people start using ZK as f of x approaches x? Because you can imagine that in a world where f of x equals x, people would use ZK for pretty much every computation because it's just like, a free benefit, right? You can just like prove that the computation was done correctly. And so, these are all examples of, things as f of x approaches x, but as it continues to move along that trend, like what additional things will we see, I think is, the exciting thing for us to discover in the years ahead.
Okay, thanks for your insights. We still have around 5 minutes for Q&A. Maybe 2 questions.
Hello, thanks. Thanks a lot for really inspiring talks. We at Ponos Technologies are actually building ZK-friendly execution environments, we could call it like this. And what we discovered is that actually there is no end of the game when it comes to cost of ZK-proof execution. Of course, if we speak about few cents, it looks like negligible. But let's say in the course of this year, Ethereum DA, thanks to proto-dank sharding and sharding itself, it will be decreased for order of magnitude at least, which will put the DA cost. And by the way, there are many other projects like Celestia, Avail, and so on and so on and so on. And it's expected that the DA cost will rapidly drop, like for few orders of magnitude, which will actually be almost at similar or the same as the cost of ZK-proof execution. Of course, it depends what kind of ZK protocol and so on and so on. My question would be related on that. What would happen if, for instance, for a real production use case, let's say gaming or whatever, you have millions of required ZK proofs per day. In that case, ZK proving cost becomes not negligible, but basically the cheaper. There is no cheap can be the better, the cheaper, the better. So that's one of things that I think in future we will anyway face. And I would like to add one more point on this, that I think that interoperability between ZKs and convergence to 2 or 3 or 10 ZK protocols will be at the level mostly of finally using standardized hash functions, elliptic curves, or arithmetic fields. I think that this is something around what is going to be centered both ZK protocols on your side and ZK computation infrastructures that we are building on our side. That's just my comment that I think we should all work together, as there is no silver bullet and there is no cheap enough ZK computation. Might be for this use case of today, but let's say in a year or 10 years from now, adoption would require really some kind of coupling between ZK protocols and infrastructures, as for instance happens with IA today. So artificial intelligence has a number of infrastructure solutions that are supporting this computation, and there is always and always new solution on both sides. So that I think that the only way is to work to couple those efforts and work together. And might be interesting, for instance, to know what kind of ZK protocols some of you is using and what is exactly cost now at some kind of, I don't know, whatever solution, probably some mainstream cloud you're using for that. Because what we heard is a kind of theoretical calculation for very unrealistic case on spot market when it comes to calculation of specific ZK protocol. So some real example and real cost would be really interesting to hear, because we have our own calculations that are a little bit different.
Well, we should have invited you up on stage. I think you make a really valid comment here about what are the, correct me if I'm wrong, but what are the practical costs for, like frankly, it's kind of an impossible question to answer without parameterizing what kind of computations you're looking to prove. I think there are always going to be certain computations that just do not fit well with ZK, right? You see that, for example, most ZK EVMs, they opt out Ketchak hash functions for Poseidon, right? And I think there'll probably always be these sorts of trade-offs that as an application developer, you'll need to be aware to a certain degree of what those trade-offs are and implement them as you're designing your application. I think it's on us and developer tooling and infrastructure teams to make that really easy, right? To alarm you whether or not you're using a computation that's going to blow up your proof generation costs. But I think to defend kind of like the state of ZK, if you design your application to be friendly with these existing proof systems, which I'm empathetic is oftentimes difficult, it is very efficient. It is there. So yeah, at some point would love to know more about your struggles.
Yeah. Any more comments?
No, the last thing I would add is I believe at some point some of these things that you will be able to prove any type of computation, in my opinion. It's just a matter of we will see many provers for different type of computations, or if we will see one to rule them all. We have seen, for example, with the hash functions, the team of Ulbetana, they released a proving system called Venus, and it allows you to use normal hash functions that are not ZK friendly. And I think at some point we will see more standardized or normal computation being done with ZK without having to decide about these trade-offs. But maybe the trade-offs are not around the computation that you do, but basically Ethereum. For example, if you want to use this proving system in particular, the proofs are huge. So I think that's where the future. Yeah, that's all.
Yeah, I think another thing I want to point out is, for example, I used to do a lot of machine learning, and even 4 years ago, it was totally unthinkable that you would have a model as big as GPT-4. Like, we were doing models that were like in the billions of parameters, and GPT-4 has maybe hundreds of billions, if not more, parameters. And I think, I view ZK in a very similar way with like the trajectory of where it's going and like how fast costs are reducing. And so I remain very optimistic that, especially with things like hardware, especially with things like ZKVMs, like as there becomes more demand, there will become more specialized hardware to make the supply side go down and just make crazier and crazier computations in ZK possible.
Yeah, if no more comments, yeah, that's the end of this panel. Thank you, guys.
Thank you.